to show you that as far as the notes go this week. And it's important to also say whether they're panelized or not panelized, or should we put a grading on our timber. All timber is graded with a number. When you go along to Mitre 10, these guys think they're pretty cool. Actually, one of my ex-students is working at the local one at the moment, which is kind of fun. And they go, oh, what do you want, an H3.5? We'll get you one of those. And they think that you kind of don't even know what the hell they're talking about. But today, I'll tell you what those numbers are. They're quite simple. And what they really mean is, can that timber be used inside a building or outside a building, really? That's what it boils down to. But there are different grades, and they also have panelized timber that fits into the ground, so you can specify that one as well. Of the 5 marks for the quantities, the one that is, oh sorry, I forgot to tell you, what will go with that one will be some of the fittings and fastenings that are required on the timber, which we'll talk about today. But they're actually labelled there on the sketch that I did anyway. So the ones that are to do with the timber go on here. The ones that are to do with the steel, which will be the Dynabolts down the bottom, and any connections that are bolted onto the steel, so that will all welded onto the steel. So that'll be the plate and the bolts that go through the plate as well. So the top and the bottom of the column have got a plate and a plate welded onto it, and so any bolts that are to do with that, washers or nuts, will be recorded on here as well. But the steel, which is the bulk of the marks, the steel will be set out very much the same way as the example that I gave you. Now the example that I did had a beam. You don't have a beam, but you do have a column, and the columns are recorded the same way in terms of the number, the weight, etc. It's very easy to calculate the column, but what you will need to do is have a look at my dimensions. A lot of students, if they've got the time, they'll start drawing up the elevation so they can work the quantities out easier. And that's the same with the timber quantities. You don't have to do that. You can do it by calculation, but it's sometimes easier on AutoCAD to draw the thing up, and then you've got an accurate recording of what the quantities are. Now with timber, if you've got a piece of timber like this that's been cut off at each end, say like that, what you've got to do is you've got to say, well, hold on, that comes out of a piece of timber that looks like that, so that's your call up for the timber. Okay? Don't do that, well actually it is that top dimension in this case, but work out what you're going to cut it out of, what you need. So it won't be the bottom dimension, it will be that dimension there. We'll need to call up. I'll talk about calling up timber anyway later on. So the steel columns are easy. The plates is up to you. What size plate you want to put on the bottom and the top of the steel member. So you have a column that kind of sits like this. I just love my little sketches. They're so useless, it's not funny, but never mind. So you have this column in 3D that looks like that when it's put sideways, and on top of that you're going to be putting a plate, 10mm thick plate. Now in plan view looking down on it, and in plan view looking up on it, it's going to be like this. Now you don't have to do any of these calculations if you don't want to, but you could find yourself in trouble for assignment 4. when I did the plate calculations the other day, last week, and we talked about the minimum and the maximum, you've got to put 4 bolts around here that work. Now some students last year managed to get the bolts in here, and that's fine. And some students managed to do bigger plates and get their bolts in the corners. Now for this particular one, that's fine as well. But you're going to have to do a detail for assignment 4 that works. In other words, your dimension to there, and that distance. And if it doesn't work, then you won't be getting any marks for your detail at all. So it's quite a good idea to work out a plate size that will work. Now before you go, oh that's easy, I'll just make my plate bigger. No worries. No, because that means you might end up with the maximum going too far for the bolt holes as well. So you do have to have a little bit of think about it, and it's not one you can copy, because I don't want to see, you know, you've done 375 by 226 or something and you've got exactly the same number. That's pretty damn obvious, isn't it? So work out one. There's lots of different numbers that will work, so just try and come up with an oddball one that no one's going to copy, and work out where the holes go for the plate. So that's the only thing with the plate. As far as marking assignment 3 goes, if you've done anything that's larger than the column, then bang, I'm going to sit here and give you a full marks. Well done, if you calculate it out properly. So assignment 3, it's easy to get your 1 mark. Assignment 2, it's easy to lose 2 marks because you've got the wrong size plate. Right? Did I say 2? Assignment 3 and assignment 4 is what I'm doing that today. So the plate is a little bit more trickier. The columns are easy. The next one is the angles. Now when we did the angle example last week in our lab, I gave you, I think it was something like 14 kilograms per metre, something like that in the example, right? Well, you've got two angles to do. Now I've given you those angles on AutoCAD. Do you remember back to last semester when you did the areas of the land by tracing a line around in the P line and listing it, and it gave you the area? Well, you can do the same with these as well. So a P line around there, if there isn't one already, list it. That gives you the area. You know the depth because I've called that up. I think most of them are 100, but you need to check that out. So you know the depth. You know the area, so that gives you the volume. So now it's only a case of doing it by the steel, multiplying by the weight of steel. And that is given, I want you to use the example we did in the lab last week as the number. There is another number on my notes, but I would like you to use the one in the example so that you can follow it through and work it through from that. So that's how you do your angles. So most of you should be able to get the full marks for that steel. Anyway, that's that. So that's one thing that you can make a damn good start on. In fact, by the end of this week, you should have nailed that, so to speak, very easily. Or say, you should be able to do that in a few hours. The bar schedule, you need to do that in conjunction with drawing it up. And I'm going to bring up in Moodle again something that I brought up last week. A lot of students can't relate any of the examples to what they're doing. I think possibly overcomplicating things a little bit. So on Moodle we have an AutoCAD drawing which we have this one. And it's got various reinforcing in it. right? And so not only have we got it as a worked example, but we've also got it as a CAD drawing. And what I want you to take particular note of is this bar that comes all the way down here like this, bends around and goes up. The exact location of where these start when working out how many there are. Because your one is a slab and it's pretty much exactly the same to the start location of the donuts. There isn't much different except for that one's longer, right? Different size. So look at the worked example, look at how you calculate the bar lengths, look at where the donuts start from, because that's not that much dissimilar to this. So you actually have a CAD drawing of that, and it's been drawn in plan view, and so that's probably the best one in terms of everything in it. Now the one I went over, the retaining wall, which I think looks something like that. You've got a worked example. And the bit that you should be looking at is this bit here. And you'll notice that there are bars that go like that. And we worked out exactly how many bars there were along here according to those dimensions. So look, that and that is the same calculations basically. And it's the same calculations for that. Lastly, I've shown you a PDF of a student example, and it's so damn close to some of the things you're going to be drawing that I couldn't give a CAD example. It would be just a little bit too easy for students. And it's this one here. Student example plan. And see those dashed lines there? I'll show you what this looks like in plan view. It looks like this. And the bars the student has drawn, the sketch they had to draw it off was this. And these lap like that. Remember, your one's lap as well. By the way, those laps are in behind each other like that and pushed as close to the cover as possible. So this example here is, if you forget about the fact that this bar kind of bends back on itself, is kind of like the upside down version of that one. So you can see how the student's done the lap here. Can you see that in the middle? And how they've labelled it. You can see the students very cleverly avoided going through any text. And this particular one, it laps in the other direction as well, which I think your one does as well. Whereas those two bars, the purple bars, are actually here and here. So I thought it was important that I give you a little sketch like that as to what that is. I'll call that the student example. So that's a third one you can work off, looking at what's there. Note, when you zoom in on some of that, there are donuts. Look at the end of the blue here. Trying to get it there nice and close. See that blue piece on the end? See how it curves? So the cover comes up and touches the edge of that curve at the end. So nothing should go past the cover. Alright? And it's not possible for donut bars to be drawn half into another bar. They have to sit on top of it. Remember, when we went over this example here, the bar came around and sat right there, right on the tangent point. The same if it was flipped. All right. Mm-hmm.
Do you have any example of the columns?
Of the columns in terms of...
Like anything that's similar to how columns can be?
Yep, the worked example in class last week had a beam. So the beam, we worked out what the length was. We worked out what the weight was per metre according to the call up of the column, the beam.
No, not the beam, like the foundations. The square on the edge of the slab.
The square on the edge of the slab.
Yeah.
You need to draw that. So it goes right round in a curve like that. And then it goes behind itself. Or under itself, so it comes around like that, like a spring.
Yeah.
That distance around there is the lap. And I suggest it's drawn with 50% on each side.
How do you label the, like I don't think there's enough room to label it without going over the edge. Can it be outside of
The lap part?
no, the like call up.
The call up for it.
Because there's also those bars that go straight down.
You remember it, yeah, the bars that go straight down here.
Yeah.
And they would have to be called up with their bar mark beside them. In that view, you don't actually call up, you would call them up very as with their, you can point to them with their call up like this. Circle, down here, and then this the call up.
Okay.
This one, because it's also a stirrup, remember?
Yeah.
So you can point to it and give it its call up as well.
Okay.
But not the other bars on the plan view. This is slightly different. This is a column. We normally detail the column sideways view. So on the sideways view, the column goes that way, and we'll put the bar on top of it, the whole number on top of it. This is a kind of flip view.
Okay.
And so there are other ways of detailing stirrups, but it gets a bit confusing. The way we used to draw them is we would curve them right around like this, right? But how to draw that is a little bit confusing for you, so I'm keeping it simple and saying when you draw it, it starts there, goes right around and ends there, and it goes hard up against the cover. And then that's how you calculate the overall length as well, which is tricky.
On the drawing, can you see those little dots for the end of the rebar? If it's all the same colour?
No, you'll draw the rebar as a P-line that goes right the way
Yeah.
around,
Okay.
right the way around, yeah, in behind itself, yeah, or over the top of the stuff. In reality, if you look at one of those sketches that I've got on my notes, they look a bit like springs. So Sometimes they will be one continuous spring all the way up. In this case, we've made it 4 of them. So that's easy to pull up for that one, but I don't want to see people aiming arrows and circles for a pull up for the other one. The other one should look more like this plane here. In fact, I'm going to go backwards on that. And pull up again. So this is more like what I want to see your plan. Now, remember, we don't show dimensions on this, so if you want to pick holes in what the student's done, they got a half a mark deleted off this for showing dimensions on reinforcing drawing. We normally, in structural drawing, we normally have a separate drawing showing the outline of the slabs, what the dimensions are, from plan view, sideways view and everything so they can build it. And then we show the reinforcing, but we don't put dimensions on the reinforcing. So, yeah, that's all I'm going to say about the assignments, and you can carry on with that when you carry on in your lab. I'd like to see quite a few notes on here. Obviously, you're almost given some notes up here to use, but I'm looking at least about 10 notes. And there's a lot of notes you can take directly from my notes as being relative to this drawing as well. So the last section here is the way how the semester's panning out. We're getting pretty close now. Is we will do structural timber this week. We will do, over the years I've experimented with this. In the first semester we had revision and you sat your test almost straight away, and I've got some damn good results. In fact, the students who did it on the Monday had a higher mark than the students who did it on Tuesday, a higher average, which is interesting. So it was in your brain, and a lot of you maybe cram swatted a little bit, but you did very well in it. This time around, it's going to be an early revision class, so next lab is the one you should be here for, okay? Now the good part about that is you've got a whole week to digest it. The bad part about that is you've also got a whole week to forget it, okay? That's the bit that concerns me a bit, but okay, we're doing it slightly differently this time.
Is it harder than
fiction? Depends. I find that the students that are best at maths are pretty good at this one. But there are 9 multiple choice questions this time. Last time was a little bit random. This time it's 3 from each section: timber, steel and concrete. It's quite distinctive. And there'll be 11 calculation ones. Yeah. So there'll be the plate, there'll be a reinforcing one, very similar to my retaining wall, but it's not quite the same. It's actually, I'll go over what it is next week. What else have we got in calculations? There's the beam, the girder as well. It's very similar to that with different numbers. And that's it. There won't be a lecture the following week. And the hand-in date for assignment 4 is there as well. You've got Queen's birthday coming into it as well. That's why we're finishing a little bit touch earlier than we normally would. And it gives you guys a good chance to study for your other tests, exams, whatever as well. So that's how that's panning out, and this week we're talking about the final set of notes, which is timber. So in New Zealand, if it's a large multi-storey building, Most of those are done in concrete. So the timber work, most of the timber work's not structural. So it'll be the interior fit out will be done in timber in a lot of cases. If you're doing a big factory type situation, combination, some are in steel, some are in timber, some are in concrete, precast slabs. But when we get down to the domestic market, of which of course Auckland's going crazy at the moment, there's a lot of timber involved in the building. Steel is just too expensive for your average person. And when you narrow it down even further, say you've got a brick and tile house or something like that, a lot of the roof structure tends to be in timber, like what I've done on the assignment. We tend to do timber trusses in New Zealand because it's quicker, it's easier, they can be pre-manufactured off-site, and they're all whacked together and delivered on a truck and stood up pretty easily as well. So timber truss design is quite relevant here. As far as qualifications go and everything, everybody keeps asking me about certified engineers, etc. You actually, to do structural drawings, even on domestic buildings, you need to be a certified structural craftsman. I think that's the term. I used to be called designer in my time. The only way you can get around that is if a structural engineer is prepared to sign it off. So a structural draftsman can draw anything that's in the New Zealand 3605 code, so anything that comes up to a certain ground level with certain sizes, certain size beams. And a lot of you will aspire to be doing that in a structural design office. The smaller the office, the more domestic stuff you're going to be working on. I'm not saying that's all you do, sit there and draw pictures of trusses or beams or structural design, but after 5 years, I think it is, you can apply to become a registered or certified draftsman. So the same with architectural, they have draftsmen that are certified as well. But structural's different. Structural would be the foundation, the tile layout, anything in the house that requires structural calculations, and anything to do with bracing as well. So yeah, the most important thing there for the to use or to do in structural design of domestic houses is timber. Now some of these notes for you guys you would have done in materials last year. Some of them will be similar. I guess I tend to pick out the things that are important for notes on drawings, and the things that are important to me in terms of what I'd like to see, the way you call it up, or the way you like that you should recognise timber. So as I've gone along looking for multi-choice questions, I've looked at the things that are the most important. And the first thing that is important to me is the moisture content. And they won't actually let you put anything on the inside timber framework of a house unless it's reached a moisture content between 14 and 18%. That's what we call the dry timber moisture content. That means the house has stopped shrinking. It's right where it needs to be before they put the internal walls on. If you're in a small company, you may be asked to go out and do this, to test this. We've actually got one of these things at Unity here. It's like a little spike. It tells you the percentage of water that's in wood. The other important thing is when timber's reached its moisture fibre saturation point. In other words, no more water can get into it. And that's at around about 26 to 30%. So keep those numbers in your mind. They are two of the multi-choice questions. Preservation treatment. This protects the timber from insects and decay. The timber is treated with chemicals, and this is where we get the word tannalised, the timber process. Now, in materials, whether it's with Roger Glanville or with Ingrid, they will go into that in great detail, the process of tannalising the timber. From a drawing perspective, it's important to know that, but I'm not going to test you on that, on the details of how it's done. But it is important to recognise how much tannalisation has gone on in the timber and how long it will actually last out in the rain. A splice joint. These are some of the terminologies that you'll come across in timber. Remember, a splice joint is for lengthening, not strengthening. So it's where we splice two bits of timber together. A lintel, in terms of timber, is a beam across an opening, which was usually a window or a door or a passageway. A tie is a member in tension. A strut is a member in compression.
This is the
Yep, all of these have been thrown into the system because I feel they're all important. A portal frame looks very much like this. It looks a bit like a house. And we sometimes build that structure to put more rigidity into an area where we're not using beams across. Those scales are important. So when we do details in engineering, we tend to do details at either 1 to 5 or 1 to 10. I have done them at 1 to 1 before, but normally it's about 1 to 5, 1 to 10. And you'll be expected to do your details for me at a similar scale. A lot of students think a detail is just a copy of whatever you've got with a few more notes. It's not just a copy with a few more notes, it's a copy and at a different scale. Now watch it. You don't want to be doing these things at the last minute because, yes, just like assignment 2, the civil assignment, a lot of you got tripped up on the wrong arrow size and the wrong text size. The same thing will happen when you do your details. So make sure that you're aware of that and you sit there and you work it out, what size the text should be, what size the arrow should be, because they'll be different for the rest of the drawing. Now, I do not want to see the details on another sheet. I want to see them on one of your 2 sectional drawings. This should be available to anyone that's got their laptops with them. That's repeated again. Apologies for that. Doesn't hurt though. Okay, so the same thing when you're building in timber. It's important to bring up the local timber place and the timber supplier that you're going to use and make sure they've got plenty of timber in the sizes that you're going to pick. It's no use to pick things, say, 25 by 75s, 30s by 75 timber somewhere, and they don't have it in stock. You might find if they've not got it, most of Auckland hasn't got it. So, as a rule, try and use the 100, the 50s and the 25s. and in some cases 75, but normally 150 and 25s are members that they've got a lot of stock in. Don't worry about this chart for your assignment. I just want you to be aware that it's important when you're picking timber to make sure that the local suppliers have got the right sizes. Because the last thing you want is to hold up on your job while they're waiting for stuff to come from the mills. The next section is devoted to types of connections. And you're a bit lucky this year. Last semester they had to do a timber truss, and we had a combination of split rings, tooth rings, and all sorts of things on that truss that they had to understand and draw in detail. So maybe, if you're fortunate enough to come back next year, you might come across these things. But at the moment, it's just for information. What I have done is, on one of the multi-choice questions, I've introduced a sketch and asked whether it's a split ring, a tooth ring, or a shear plane. So you need to have a bit of a look at those just to familiarise yourself with what the difference is between each one. So as a sketch, and I'm asking, is it a tooth ring, a split ring, or a shear plane? And I've taken one of those sketches there. The most common form of plate is what we call a gang nail plate. And normally these are compressed with a machine onto trusses. You see here a truss being something roughly like this. Different sizes and different bracing members. But this detail here shows the same as this detail here, and it shows how they have plates either side. They put the timber together and they go bang with the compression. And these little things here are a series of little, they're like nails. They stick up, and when they get compressed down, they go into the timber. So these are what we call gang nail plates. You can also put them on with a hammer, the old-fashioned way. And other ways are these framing anchors, often called Z-nails, and these framing anchors here as well, which are put in by screws. These are also ways of tying a house down to the piles, and it's the most common way of doing it would be these bottom two. And because I had to get under a house and do this all day, I've made that one of my multi-choice questions. By the way, if you've got boy racers in your street and you're getting sick of them, these things are wonderful for putting on the road, because no matter what way they fall, they always land up with one little spike in them. Not that I would do that in my street. At least cut that out of the video. Rough, sawn timber, gauge timber, and dressed timber. Okay, we're getting into the crux of what I want to see on the drawings. So when I talk about rough sawn timber, basically they mill it to the size that is required. So in this case, 150 by 100. It's a cross-sectional view. Rough sawn is fine for underneath decks or for different structures like retaining walls, things where it doesn't have to look pretty. But in a lot of cases with domestic builds and things that will be seen by people that you want to paint, we tend to go for the next thing, which is gauged, where they run another cut through it, take off all those burry bits and make it quite smooth. And finally, the final cut, which is the dress cut with a finer tooth saw. So what in actual fact is, you may ask for a panelized piece of timber that's 100 by 50, but if you specifically want it dressed, you need to be aware that it will be 90 by 140. So let's look at your building. your sketch. It's the inside of a meeting house. People will be looking up at it, so it'll be exposed. So it can't be rough sawn. It's probably going to need to be at the very least gauged. So when you're calling it up, you can still draw it at 150 by 100, but when you're calling it up, you need to call it up as gauged. That's just a table of, similar to the previous table with the lengths involved this time that the company's got. How do we show timber in sectional view? Okay, so there are 3 different ways we can show it. If it's dressed timber, which none of your timber is, you'll show it like that bottom symbol. If it's blocking, and you say, well, what's blocking? Blocking is when you put a bit of timber between 2 other pieces of timber to hold them apart. So this might only be a very small piece of timber. Might only be a piece of blocking in there like that. Okay? If it's only a bit of blocking, then we tend to show it as a crisscross. If it is a continuous member like the black ones, and we've cut through it, we tend to show it. Sorry, blocking is just one cross. A continuous member is a crisscross. So with timber, if you're showing any details, which you will be, through the purlin up the top, then a continuous member needs to be shown as a crisscross. There was a time I hardly had anyone tune up to my lectures. Now with this signing and everybody's here, I'm giving away all my clues, aren't I? Don't mind. With the call up, you're going to need to just going over that in the call up, you're going to need to call up gauge timber for most of the members because they're going to be exposed as you look up and they'll need to be painted. And the next thing you're going to need to do is, in a detailed situation, you're going to need to detail anything you're crossing through with a crisscross. Timber connections. We don't have any of these connections. These are exactly the same as the others, but they're a sideways view of them. Quite nasty looking things, aren't they? Basically, they clamp the timber together with a bolt and, I guess, teeth, really. Hence the name split ring or tooth connections. And this is how last year's we're expected to draw it up in detail. It's there for information only. And here's some details of some structural drawings and how we do them. This one here might be of particular interest because you've got bolts going through angles onto purlins. So this is how we call up bolts. We tend to dimension to the bolt, and then we will put something like 4 bolts at whatever centres. So that's how you would call them up on your plates as well, by the way, on your detail. The next thing of interest is washers. When we're bolting any timber, we always use a washer. When we're bolting steel, we don't need to always use a washer. It's advisable, but it's not 100% necessary. But with timber it is, otherwise the nut will keep on going into the timber. So we need that washer there. So if you're doing any bolting into timber on your assignment, don't forget to add the washer onto your quantity sheet. And that's how we call up nails. We're not going to be using nails on this particular assignment. Oh, there will be nails, but we're not specifically calling them up in our structural detailing. Bolts. There are a number of different types of bolts. An example of where you would use this bolt would be to put a handrail on top of a bridge. So when people go along, they're not going to, you would recess this bolt down. It's a lovely curved top. They're not going to jag themselves on it as their hands go along. That's actually one of the questions. Coach bolt, where would this possibly be used? Here's what we call an engineering bolt. And here's how to draw it up. These tables show how to draw up these bolts according to the distances of the thread, etc. So this may help you also in determining the length of the bolt that you put on your quantity sheet. You've got a coach screw on your assignment. Pretty sure you have. So the coach screw doesn't have a bolt at the end, it screws into timber as a thread. Nails. One of the questions in my question bank has got a double-headed nail on it. So it looks like the top one. There's two questions on nails. One is directly from that table. Well, one is one of those. So you're asked what type of nail it is. The two most common ones would be the flathead and the jolt head. Angler groove and spiral. These are used predominantly in places like the islands where they have a lot of cyclones. They'll put those on the roof to hold the roof down, give it more grip during heavy wind. Can anyone think why you might have a nail with two heads on it? Hang something off? No. What if I said I'd give someone half a mark if they could guess it?
Easy to remove.
Easy to what?
Easy to remove.
Easy to remove. How do you mean by that? So you get your claw hang it through there. You're on the right track. Where would you use it? Yes. Temporary, yeah. So give me an example.
That like a washer, that's like a washer, might go inside the timber, after
yeah, so what you're saying is normally if you put it inside a timber,
the inside it might go inside the timber.
Yeah, so it's hard to pull out once that's flat with the timber, right?
Yeah.
Correct. You are correct in what you're saying. So that will stop it at that point, so you can pull it out easily, right? So give me an example and you get your half mark. I'll give you a clue. Last chance. I talked about this in week 8 with concrete. Who said that? Some of it. Yeah, that's 100% correct. Okay? Framework, almost. Formwork's the word you're after. So when you're putting up the concrete formwork, and you've got this bracing going like that, and what we tend to do is we tend to use these type of nails because you just go bang, bang, bang with your nail gun, and they're sticking out like that, and you have your lacquer or your oil or whatever coming behind you after the pour, pulling it all off, and reusing this again on the next section. So you might do, I don't know, 100 metres of retaining wall, and you do the pours each time. Very close, I'm sorry, but you need to email me before Friday. Remember that, if it's after Friday, like somebody did on Sunday night, they didn't get their half mark. Can't go on forever.
All right. I feel like a kid at Christmas time, but Santa Claus will be lollies.
You get married?
You done?
You get married?
Yes, I've got rules. You're pretty quick. You can move. Got all your names, so we're marking them up hard.
Oh,
Every cloud, eh? Okay, so I thought about the test, and I thought long and hard about what are also important things with timber, and I decided that I wanted everybody that goes through this course to learn New Zealand building terms. It doesn't matter whether you're a surveyor going on site that has to measure to the fascia plate, height to boundary, or whether you're an engineer on site that's just checking that the footing reinforcing has been put properly. It's important to know building terms. And there's a number of these things are the same right throughout the world. But I've been watching some of those builds on Sky TV, they're building in Alaska and building this, that, and the next thing. And all different countries have different names for things. And I guess this is a New Zealand qualification, so it's important that we incorporate some things. Now, where I come from down in Dunedin, even further south, somebody down there got sick of the word nog. They didn't like it, don't know why. They're a bit weird down that way. And they called it a dwang, D-W-A-N-G. So if you end up working south of the Bombay Hills, down in the South Island, it's quite likely someone will talk about dwangs. And it's a weird, it sounds like a beginning of a country song, doesn't it? And I thought, no, I'm going to put that there, and that is something I'm going to make my students learn. So in New Zealand, dwang or nog are the names for these members that are in between. And this one running this way is called a stud, and that seems to be what all the countries call it. We have our footing, if it's on piles, and directly on top of that, that black thing you can see there is DPC. DPC stands for Damp Proof Course. That is also a multiple choice question. I've used all sorts of names for that. Damp Proof Course. What it does is it stops the dampness or the moisture coming up and getting into the timber and rotting the timber. Usually there is a plate, and there we are, that's a long piece of what we call blocking. Then we have the bottom plate, which is usually 100 by 50. And then we have the wall structure. On top of the wall structure is the top plate. Then we have the ceiling joists, which is where we often put the jib board on to that afterwards. We have a rafter, ridge board. Now you've got a ridge board and a rafter on your assignment this year. And the purlins run in that direction off the roof. Coming down to the floor, we have the floor joists in that direction, and the bearers running along on top of the piles. So you will from time to time go to site with these things in different stages of production. And as far as surveys go, they normally have to set out the foundations for these, set out the pile design, where the piles are going to go, and later on they'll come back to the job and they'll check to the fascia plate. Normally, that fascia plate won't be on there. That piece there will be. So what they need to do is another calculation to add the fascia plate on to make sure that it's still not going to infringe on height to boundary. And if it's wrong, if it's too far, they'll go all the way along in with the chainsaw and they'll take that much all the way off before they put the fascia plate on. Very important to do that before you put your roofing iron on. You got the roofing iron on, it's too late. It's a big, major rebuild. So the survey's job is extremely important because if you don't get sign-off, height to boundary, then you've got to apply for resource consent. If the neighbour won't sign it, you'll never get your code of compliance to the house, which means you'll never sell it. Most overseas buyers will not buy houses without CCC, code of compliance. So from an engineer's perspective, you could be talking about any of these members on a house because you may be asked to brace any of them in any particular way. With diagonal bracing, this is the old-fashioned timber way. We tend to use steel now, and also jib bracing on the inside is often used as well. And you'll do calculations for that, and you'll come up with where the bracing units need to be in a house. And you'll have to talk about all those units in the time. As far as kind of industrial buildings go, or large sheds, these members up here are important. You've got the lintels over the top, the purlins running in the same direction, the roof trusses, what we call a knee brace at the end of the building, and the sheathing on the building is often fixed to what we call girts, which is a strange word, at the end of the building. Both of those charts, there are 4 questions over those 2 charts. So you do need to learn all the terminology. And how do I do it? Well, I blank out the letters and I go A, B, C, D, E, F, G, H, I, all the way around. Maybe, if you're lucky, they'll be in that order. And then I'll say to you, what letter represents the floor joist? What letter represents the dwang? Okay? You'll have to give me the letter as part of the test. There's some typical drawings here for a deck, or a bridge, sorry. Bridge or a wall? A decking, okay? So this is how we often show decking on a building, where we expose the under side of it, the members underneath. So we only show a small section like this, and we show the work, what's underneath the deck like that. 2 semesters ago we did a bridge which had timber members on it, and the students had to draw it like this. I'm actually a little bit overdue a bridge, so that could well pop up next year as well. You guys? For information only. Alright? And that is a little wharf of some sort, is it? Once again, it shows you how we do our details. Now, I know it's only a sketch, but you'll notice that to do a detail, we do a little circle and a bigger circle. So if it's a blow-up of that, that's how we do what's called a blow-up detail. And that, you've got a blow-up detail of the purlin connecting to the angle. So that's how I expect you to detail it on your sheet. So you'll have the elevation, a little circle around it, to a bigger circle with the detail in it. And you'll be quite proud of yourself when you finish it. It'll look quite good, look very professional, I'm sure it will. Lastly, and also to do with the call up, is the grade of the timber. There's some notes there on the different species of timber, the native timber versus the softwoods and hardwoods. Well, it is mostly for information. We do draw mostly in Pinus. We do build mostly in Pinus radiata in New Zealand. The only time when we tend to differ a little bit from this is if we're doing buying decking. Sometimes we'll use a native timber for decking, or a native timber for something like cedar for decoration. So with the Pinus, or the Pinus, as it is shortened to in terms of its what we call it, there's different grades and qualities, and there are ways of protecting from fungal decay and insect borer, for example, and I'll detail those. You don't need to go into those in great detail. There is a couple of questions that comes from this section here, but if you read through it in your time, you'll see that the questions aren't too difficult if you read through it. In fact, they're very easy. So, for example, they might say, which one of these is not a common household borer? So you've got the two-tooth, longhorn, the common house borer, and the powder post borer are the main ones. Big pardon? Oh, what about all the people alongside it? Together. So, as I said, the most important part here, which I'm going to go into a little bit more detail, is the grading of the timber. So when you're calling up the timber, don't just copy my notes. If it's a pile situation where the timber's going in the ground, make sure you put H5 beside it, which is what we call pile timber. H5 is the treatment, and that's the highest treatment we have in New Zealand. I believe there is also a marine one as well, but we won't get into that in this class. So when we go right back, it starts at 1 and goes through to 5. So 1 is the least amount of tannalization, and really, if you're going to use it for framing timber, you put it up and you get the house closed in as quickly as possible. The longer that 1.2 is left exposed, the more chance it's going to end up a leaky home or a rotting home. This is one of the big issues that happened with our leaky homes back in the 1990s. New Zealanders were building in basically H1.2 or less, and they expected that that would be fine. And we didn't have the right air gaps. We just had polystyrene with plaster on it, and the water went through all that and straight onto the framing. And obviously it rotted. It rotted pretty quickly. We're getting the rotting happening within a few years of the houses being built. Nowadays, they don't use that type of framing. They use a lot more tannalized for the framing, the grade. B, they put in a wrap around, then they have an air gap before they put the exterior cladding. So that air gap allows for any moisture that gets in there to go down through the gap and out the bottom before it touches the framing. So things like veranda posts, which will be exposed to the outside, would be 3.2. Anything inside would be the likes of framing for walls. Exterior walls would tend to be 1.2, whereas framing for the inside walls would be more like 1.1 framing. There's quite a big difference in the tannalization and in the cost. Unpainted or clear exterior, 3.2. Decking, the decking timber that you buy is 3.2, just to give you a bit of an idea, and that normally lasts 20 to 30 years. And exterior plywood is 3.1. Fence posts. Fence posts are H4 because they're in the ground, They don't have the same treatment as the H5 piles, which are under the houses. So that's something to remember. That is one of my multi-choice. The other one is off this chart as well. Actually, there's two on this chart, off the top of my head. So basically, I've said, which would be an example of H3.2 timber? And obviously, the real answer might be that one, but I would add in other ones like H.1.1 and 1.2. So have a look at that table. Have a look at where things are and the type of treatment that we normally give those items. And this table here represents why, starting from 1.1, where we would put it. So low risk areas with of dampness, moderate dampness, external use, where there's going to be 3 paints on top of it to give it protection, and then finally 3.2 external use, and H4 where it's in contact with the ground. So those two tables, that one and the bottom one, I've taken at least 2, maybe 3 multi-choice questions off. So they would be another one I would tag to look at before the test. So just in summary of what we've done today, and that's it. You can disappear off into the wilderness after that. Assignment quantities. Make sure you call up the timber correctly on the quantities. We also talked about any bolts requiring a washer. If there's a nut at that end, it'll need a white washer at both ends. If it's just a screw type situation, then it will probably just need a washer on the one side where the head is. We've talked about the tannalization. These numbers are really important. We've also talked about whether the timber is going to be gauged or rough sawn. For the assignment in the detail section, there's some examples in there, but there's also, you've also been told the right way to draw the timber, whether it's across or sideways through it. And of course, I've gone through and given you some good tips towards the test in terms of the timber side of things. So that's the end of the formal notes. Next week I'm going to go over the mathematical side of things for you. So we'll go over the example that's in the test. In the test, we're doing an abutment this year. So it'll look like that. Bridge abutment. So what happens is the bridge beam sits on here, and another beam will sit on here and introduce the road section. So you've all gone over bridges before, and you have that clunk clunk when you go on it, and then clunk clunk when you come off it. That's these pieces here, where the beam sits on here, and the introduction roading, normally a piece of concrete, sits here, and then it goes across the bridge to the other side where you have an abutment on the other side. So we're going to do some abutment reinforcing. It's very, very similar to this one here, and I'll cover that. I'll also cover bolting again next week, and that's about it. Any questions at the moment? No? Okay. So this week's lab is just carrying on with the assignment. It's important that you at least turn up to sign the roll, or else they'll start ringing you up. But if you want to do the assignment at home, then I'm fine with that, as long as you sign the roll, big home. No, but if someone asks a question and I think everyone needs the answer, I'll say it. If you're not there, you're not there. Yeah. So please sign the roll that week and at least turn up to your lab and sign that before you take off.